7 says that you can explain the polarity and the properties of polar and nonpolar compounds. So just to review quickly, a compound is multiple atoms joined together in a fixed ratio. So in English, that means that something like water is a compound because it has to have 2 hydrogen atoms for 1 oxygen atom. So if I were going to draw water, I like to say that water looks like Mickey Mouse, kind of. And these small circles here are hydrogens, and this large one is oxygen. Now here's the deal. Oxygen's really big, and it's significantly bigger than hydrogen. And we know that electrons like to circle around the nucleus, and one of the things that prevents them from flying off into space somewhere is the fact that the nucleus is dense and it contains positively charged protons. So since oxygen is so much larger and has so many more protons, what ends up happening is it ends up hogging the electrons, and the electrons seem to stay on the oxygen side, or oxygen half, much more often than they stay on the hydrogen half. And as a result, if we were to draw a dotted line through the center of the molecule, what we would notice is that this side, the oxygen side, would have a slightly positive charge, and the hydrogen would have a slightly positive charge. I don't know if I said that correctly. The oxygen would have a negative charge. The hydrogen would have a positive charge. And because this molecule has opposite charges to it, we say that it is polar, just like our planet. Okay, so oh boy, let's imagine that this is some continent. Okay, so this is our planet. Our planet has these poles on the ends of it, and it actually has an electromagnetic field around it, and the opposite ends have opposite charges. Same can be said for a molecule that is polar. Okay, so it is polar, it has opposite charges. Now, this gives it some unique properties. If a compound is polar, then we say that it is hydrophilic. And hydrophilic means that it is water loving. Okay, it's hydrophilic, it is water loving. So if we split this down the middle, we have a negative charge on the oxygen end, a positive charge on the hydrogen end. We say that this is polar. Water is a perfect example, and we can also say it's hydrophilic or water loving. Now, if something is nonpolar, what that means is that the molecule has basically the same charge throughout. And I'll give you a general rule of thumb. General rule of thumb would be that if you can take a molecule and you can split it right down the middle, and it's a mirror image of right and left, it's a mirror image of itself, then it's probably going to have a consistent charge throughout, or virtually no charge throughout. And if that's the case, then we'll say that it's nonpolar. Okay, so if it's nonpolar, then it is considered to be hydrophobic, which means that it is water fearing. Okay, so if it's nonpolar, it's water fearing. Another thing about nonpolar substances such as lipids, fats, oils, steroids, cholesterol, all these things, they do not dissolve in water. Okay, so if it's nonpolar, it does not dissolve in water. A good way to know if something is nonpolar is if you can draw a line right down the middle of the molecule and it's a mirror image of itself from left to right, and we would refer to this nonpolar molecule as hydrophobic.